Hello everyone, welcome to Mind Maps. And I have a good news to share with all of you. We have crossed 100 plus subscribers on YouTube, and it has been an amazing journey so far. I will admit that I haven't been very consistent, and there is a lot of stuff that I have planned out for the videos that are going to come. Today I thought we can start with name reactions, because I don't think you'll need anything other than the basic background to go through these videos. I'll try to make them as soon as I can, because I have a time crunch as well. But still, it was very soul satisfying to finally have reached this mark, and I want to thank all of you to have shown trust in this channel and helped it grow. It really means a lot. अगर आप अभी भी समझ नहीं पाए हैं कि क्या इतना क्यों मैं टाइम वेस्ट कर रही हूँ यहाँ पे, या फिर आप जो भी कहना चाहो, बट अब ऐसा कोई स्पेशल वीडियो तो है नहीं कि 100 प्लस सब्सक्राइबर है, तो मेरे लिए स्पेशल है ये मोमेंट बहुत, क्योंकि पिछले महीने बहुत कुछ हो गया। तो आपके टीचर को डेंगू हो गया था, और तब मैं हॉस्पिटल में एडमिट थी, बुखार था, बोतलें चढ़ रही थी और बहुत बुरा हाल हो रखा था। लेकिन हाथ में फ़ोन था, नेटवर्क भी नहीं था ज़्यादा, लेकिन फिर भी जो एक यूट्यूब का एक ईमेल आता है आपको कि आपके 100 प्लस सब्सक्राइबर्स हो गए हैं, तो वो देख के बहुत अच्छा लगा। सच में बहुत बहुत ज़्यादा सुकून मिला। तो आप सभी को थैंक यू, और मैं आशा करती हूँ कि मैं और भी वीडियोस में बनाऊँ आप सबके लिए, जो कि आपको हेल्प करे किसी भी तरह, भले कोई आप एग्ज़ाम के लिए पढ़ रहे हो या फिर नॉलेज के लिए पढ़ रहे हो, और जो भी आप इससे अचीव करना चाहते हो अपने गोल्स को, वो आप करो। ये मेरी आपके लिए दुआ है। और तो चलिए फिर स्टार्ट करते हैं। ठीक है, स्टार्ट करते हैं आज का लेक्चर। आज हम पढ़ने वाले हैं नेम रिएक्शंस। ओके, ये सीरीज़ एक स्टार्ट होगी, पूरी प्लेलिस्ट बन जाएगी, और उसके बाद एक के बाद एक आप देख सकते हो। तो हम स्टार्ट करने वाले हैं हॉफमैन रीअरेंजमेंट से। ओके, और कोशिश की जाएगी कि हिंदी में भी बोला जाए, इंग्लिश में भी बोला जाए, और किसी को कोई दिक्कत ना हो। नोबडी हैज़ अ प्रॉब्लम विद दिस। सो विल स्टार्ट विद हॉफमैन रीअरेंजमेंट। ओके, हॉफमैन रीअरेंजमेंट. If you listen to this name reaction, there are a few things that should automatically strike you, and then they are: this reaction is related to preparation of primary amines या primary amine. कुछ भी अगर नहीं याद आए तो आपको इतना पता होना चाहिए कि this is a reaction that is related to synthesis of primary amines. कई बार हॉफमैन डिग्रेडेशन भी बोला जाता है। ये एक रीअरेंजमेंट रिएक्शन है, और हम उसी कैटेगरी में इसको स्टडी करते हैं। और इसमें सबस्ट्रेट क्या होता है? एक अमाइड होता है। अमाइड से क्या बनाते हैं? एमीन बनाते हैं। दूसरी एक इम्पॉर्टेंट बात जो है, जो आपको जाननी बहुत ज़रूरी है, वो ये है कि इसमें जो प्रोडक्ट बनता है, दैट इज़ 1 कार्बन लेस. ओके, 1 कार्बन लेस. अभी हम रिएक्शन पे भी जाएंगे, पर अभी हम समराइज़ कर रहे हैं इस वीडियो लेक्चर को, कि आपको अगर कुछ भी नहीं याद है तो आपको ये सब चीज़ें आपको पता होनी चाहिए कि होता क्या है. देन यू कैन वर्क आउट द रिएक्शन और द रिएक्शन मैकेनिज्म योर सेल्फ. आप खुद से भी लिख सकते हो, ठीक है, अगर आपको पता है कि इस रिएक्शन में होता क्या है. तो कुछ याद करने की ज़रूरत अभी तो नहीं है. खैर, I'll try to make this video as detailed as possible. So let us look at the reaction. So this is Hoffman Rearrangement. यहाँ पे हमें एक बेस चाहिए था, स्ट्रॉन्ग बेस है, आप देख सकते हो. ये क्या है? स्ट्रॉन्ग बेस है. बेस, ओके, in presence of Br2. Okay, we have a strong base in presence of Br2. This is an amide. Okay, alkyl amide. COO NH2 is an amide, and we get a amine. If you look closely, as we discussed above, this carbon is missing here, so there is 1 carbon less. This is one of the few things that you need to observe about this reaction closely. नीचे हमारे पास जो है, below this we have the balanced equation. You can see we have 3 substrates, मतलब 1 substrate, that is obviously 1 substrate, and these are the reagents. Okay, and then we have a primary amine, salts and water. Okay, so there's water. One of the things that you can make out or guess from this reaction is there is hydrolysis भी है यहाँ पे, तो वो हम reaction mechanism में देखेंगे. We will see that in the reaction mechanism. So let's have a look. So this is the mechanism. It is written over here. First we have the substrate. The step 1 involves reaction with bromine. Okay, you can see there are 2 hydrogens attached to the nitrogen. What can happen? 1 hydrogen can be replaced by bromine, and then we'll have this product in the first step, that is N-bromamide. Okay, N-bromamide. Is that understood? Okay, this is nomenclature, how we name amines or amines. In the next step, what will happen? There's another hydrogen that needs to leave. Okay, so when this hydrogen leaves, -H, then we'll have this intermediate. Okay, this is an intermediate. This is given in a bracket. Okay, there are brackets. So this is a concerted process. We have a negative charge on bromine. Okay, there's negative charge on bromine, and then there will be loss of bromine. Okay, in form of KBr. I hope that's all right. What will happen after this? There will be a negative charge on nitrogen. So this is the step 2 of the reaction, kind of step 2. There's 1-2 migration, 1-2 migration. Okay, 1-2 migration. The negative charge is goes to the carbon, and then there will be a formation of double bond, and this R group, this alkyl group, will go to the nitrogen. This is acyl nitrene. There's 1,2 migration. This is also a concerted process. This is given in brackets. So after this arrangement, this rearrangement step, we have a product that is known as alkyl isocyanate. Okay, there's RNCO. What do we have here? There is C to N migration. Which group is the migrating group? R. R is known as the migrating group. The migration is from carbon to nitrogen. Just have a look here. Here the R group is attached to the carbon, but in this intermediate the R group is attached to the nitrogen. I hope I'm clear. Again, the migrating group is R. Okay. Where does it start? At carbon. It is joined at carbon. The terminus is nitrogen. And we get an alkyl isocyanate. This is the product that we get after the migration. After this, when you react it with H2O, this bond, one double bond is broken and an OH is added. Okay, this is known as carbamic acid. C R N C double bond O OH. Okay, if there was no N, it would have been an organic acid, a simple organic acid with R as alkyl group. This is carbamic acid. For the sake of convenience, let us say it's C2H5. And then what will happen? The step 3 is हाइड्रोलाइसिस. जो लास्ट स्टेप है वो हाइड्रोलाइसिस है. हाइड्रोलाइसिस में क्या होगा? कार्बन डाइऑक्साइड निकल जाएगा. ओके, एंड एक H प्लस ऐड हो जाएगा. 1 H प्लस विल बी एडेड. वी गेट RNH2. दिस इज अ प्राइमरी amine. Okay, and the CO2 that is formed as a byproduct is released. तो ये हो गया स्टेप 1 में. हमने क्या किया? स्टेप 1 में N ब्रोमोमाइड बना. ओके, नेक्स्ट स्टेप में ब्रोमीन निकल गया, नाइट्रोजन पे लोन पेयर आ गए और वो लोन पेयर से डबल बॉन्ड बना. R ग्रुप है वो नाइट्रोजन के पास माइग्रेट हो गया. असाइल नाइट्रीन बोलते हैं. फिर उससे जो बना उसे बोलते हैं हम एल्काइल आइसोसाइनेट. यहाँ पे वाटर से रिएक्ट किया तो कार्बमिक एसिड बनी. फिर हाइड्रोलिसिस करके प्राइमरी अमाइन और बाय प्रोडक्ट में कार्बन डाइऑक्साइड. तो ये थी मैकेनिज्म. अब एक चीज़ जो हमें जाननी है कि ये जो प्रोसेस है, दिस इज़ एन इंट्रामोलिकुलर प्रोसेस. ओके, इंट्रा मीन्स जैसे फेस्ट होते हैं, देयर आर कॉलेज फेस्ट और कॉम्पिटिशन्स इन योर कॉलेज. when there are more colleges involved, it's called inter college. Okay, when you're competing with students of other colleges, that's inter college. And when you're competing with your fellow college mates or within the college, that is known as intramolecular. Okay, within the same molecule, if something takes place, it's intra, and there's another molecule, then it's inter. This is a intramolecular process. That means the migrating group, whatever happens, it goes back to the same molecule itself. It does not go and attack some other molecule. So there's no free alkyl migrating group that can roam around in the reaction medium. Okay, it is a concerted process and it takes place within the same molecule. Okay, for example, when we have a carbocation and it can go anywhere, suppose we have Br minus, it can go and attack any one of the carbocations for the sake of explanation. But here what happens, no interprocess takes place. Okay, next, when we have a reaction like this, say we have an aryl amide. Okay, this is a deuterated aryl amide. There's D, there's deuterium, and we take another molecule of aryl amide. Okay, but here we label a nitrogen 15 isotope. You know, when we attach isotopes to compounds, they can be easily detected by spectroscopic methods. So what happens here is, when we react this with bromine and KOH, these products are formed, the one given above, NH2 and D, and NH2 labeled as 15. So when you look at the other products, these are cross products. Here you can clearly see there is nitrogen 15 and deuterium on the same molecule, which is not possible if the reaction was intermolecular. So this is how we prove there is no separation of migrating group from the substrate. Okay, so there are no cross products. क्रॉस प्रोडक्ट नहीं है. क्रॉस प्रोडक्ट का मतलब क्या है कि ये नाइट्रोजन जो है, ultimately this nitrogen will be attached to carbon, will go here. Okay, so if this group say went here, there would be no deuterium. Okay, like this, but it does not happen. Okay, there is no cross migration of groups. Actually the carbon migrates to nitrogen. That's the case. Just let's not be very specific in terms of details, but you should know that the C to N migration is there. Say N migration is there and the migrating group is R. It migrates from C to N. Okay, so this group should technically go here. It cannot go on the second molecule. Okay, if say this is the migrating group, let's say there's NH2 and there's N15 NH2. Okay, so this can go here or this can go here, but it does not happen. Okay, so this was originally attached to this molecule which has a deuterium. So only a simple nitrogen derivative is possible, not the isotope one. The second evidence that we have is the migrating group does not separate away from the molecule, and when we react a certain molecule like this, what happens? There is retention of configuration. Okay, there is no change of configuration. That also suggests a reaction mechanism that is similar to SN2. Okay, sorry, SN2 there's inversion of configuration, but here there's retention of configuration. That suggests that there is no separation of migrating group. Okay, I hope I'm clear. Because in SN1 and SN2 we have the nucleophiles and they are free to move in the reaction medium. So in SN1 and SN2 they are free to move in the reaction medium, but here the reaction is concerted. The migration takes place within the molecule itself. So let us look at a few applications. The applications are very simple. What you need to do is, we have an amide, and what we need to do is, whenever you see Br2 and KOH, there is formation of a primary amine. What is a primary amine? Nitrogen attached to one carbon atom. Okay, similarly, just have a look here. We have CONH2. When we do add NH2 group, we get CONH2 and that converts into NH2, and there is CO2 that is released. For example, in nicotinamide, we react this compound with Br2 and COH, we get a primary amine. Okay, then we have phthalic anhydride. When we react it with ammonia in presence of water, we have phthalimide. I hope that makes sense. And when we add Br2 and KOH, there's a different product found. Technically there should be, both these groups should be reduced to NH2, but that does not happen. One group is reduced to acid, one group is acid, and only one is a primary amine, that is known as aryl amine. This is a different mechanism that takes place, and I think this is an important example that you should keep in mind for any future reference. Okay, so one more thing that I'd like to discuss is, say there's a group attached, a group is attached to the molecule. So what will be the rate of reaction? Okay, so that you need to find out if it's electron withdrawing or electron releasing. What will happen if G is electron withdrawing or electron releasing? Will the reaction rate increase or will it decrease? So all of this depends on the groups that are attached. Okay, it can increase or decrease a reaction, and that you have to find out. Okay, why that happens? Then one of the few key questions that you need to know are, what is 1-2 migration? Why does it take place? The intermediates that are formed in brackets, a little bit of hydrolysis, why do we use Br2? These are all the questions that you need to ponder about. Okay, when we talk about name reactions, the general notion is that it is dedicated to a scientist, right? It is dedicated to the scientist, and they discovered a certain method to prepare something, and they use these particular reagents. like BR2, like KOH. Okay, so whenever we study name reactions, the reagents and the substrates, they are very specific. The reagents are very specific, so they are honored in their names. I hope this was an interactive video and you could learn more about Hoffman rearrangement. Thank you so much for this lovely response, and we have crossed 100 plus subscribers. It just makes me happy and happier to see this number growing. And till the next video, goodbye.